Okay, we're just going to continue working through these identities. I want to go slow and make sure that any questions that you guys have that I can answer. We'll try to get through this first page in a little bit in a second, but we're just going to try to get through as much of these next 4 pages as we can in the next 2 days. Okay, and that way we can spend Monday to review and Tuesday quiz. Okay, formula sheets will be given to you, so you don't have to memorize any formulas. Okay, just have to know how to work these problems. I want to start with number 1 again. I know that we went through it, but I want to kind of walk through it again and just to kind of have, because this is the one that has so many parts to it. So let's start with let's go through number 1 again. Okay. Usually the pattern is that we are starting on the left side and we're trying to get it to look like the right side. Don't think of it as an equation where you're moving things from one side to the other and you're trying to solve an equation. Basically, you're just working on the left side expression and then trying to find versions of it until you can get it to look like the right side. Okay, so we started off seeing that one pattern. One thing we noticed at the very beginning is that the trig function is distinctly different, right? Everything on the right side is in terms of sine and cosine, so that kind of helps me to gives me that first step. Okay, what if I just quickly combine or convert my secant and tangent to be in terms of sine and cosine? So that's what we did first, right? Secant is 1 over cosine. And then tangent is sine over cosine. So what made this a little bit more difficult than the previous ones were, we have a complex fraction, we definitely want to multiply by the reciprocal, but this is still unresolved. We want to get this down to 1 fraction, which means we need to find a common denominator just for that numerator portion. So we're going to play with that numerator until we can get that common denominator. This 1 is really a 1 over 1, which helps us see clearly that a common denominator is going to be cosine of x. And then we look to balance each of our fractions. This does not need any balancing. We bring down the 1. This, from old to new, we are missing a cosine, so I need to multiply this numerator by cosine. So I'm left with 1 plus cosine of x all over sine x cosine x. Sine x over cosine x. We are making progress because we have a common denominator, which means that we can merge these together, and also then we can have an easier time bringing this up and canceling things out. Okay, so do one final merging here, 1 plus cosine of x over cosine. Dividing by a fraction is the same thing as multiplying by the reciprocal, so I'll bring the reciprocal up. Sine over cosine becomes cosine over sine. So we are making progress. At least we got the cosines to go away. We are in the same functions as we were before. I mean, as the right side. So we are making progress there. 1 plus cosine over sine. So this is where we are. But even though we are dealing with the same functions, we are still a little bit off, right? We want that denominator to show 1 minus cosine, but our denominator is currently showing sine. Everything's already, there's no trig identity that's popping up right now. There's nothing else that we can convert. So this is where we're kind of creating something out of nothing here. We want to get that sine in terms of cosine. One way we can quickly do this is involve a trig identity. There's no sine squared, but maybe we can introduce a sine squared. Okay. It seems strange, right, that we're just adding something to the problem, but we can maintain balance by also including a sine x in the numerator. Sine x over sine x is basically 1. We're introducing it so that we can have something to work with using a sine squared. So I'm left with 1 plus cosine of x all over sine squared x. Now, there's an identity that we can work with. Sine squared is the same thing as 1 minus cosine squared. So now this becomes a lot more familiar, right? Because we know that at least we have the right function in the denominator. And now we're thinking, okay, I can maybe find a match for the numerator by factoring, right? We recognize this as difference of squares. Break this 1 minus cosine squared down into 1 minus cosine of x times 1 plus cosine of x. We get the two matching parts to go. And then we're left with sine over 1 minus cosine x. And that's exactly what we want. That matches the right side. Okay, moving on to number 2. Number 2, we have cotangent of v minus 1 over cotangent of v plus 1. I would like to get my trig function in terms of tangent. So what can I do with cotangent here? Yep, convert to be 1 over tangent, right? But it's going to be within the fractions, so there's going to be some common denominator, some complex fractions we have to resolve. But we can start off with this, right? 1 over tangent of v minus 1. I'm sorry. Let me do that again. Okay. We know that this cotangent, it becomes 1 over tangent. So 1 over tangent minus 1 all over. Cotangent, replace this with 1 over tangent. All right, that's ugly and messy. We got complex fractions all over the place. So we got to take care of, first things first, we have to resolve the numerator portion into a common denominator. And then we also need to resolve this to be a common denominator. Okay. So I'm going to force the denominator out of each of my missing denominators. So let's look at the top portion first. What's my common denominator within this top fraction? Just tangent v, okay? So tangent of v in my denominator for both my fractions. Okay, see if we can do any conversion here. There's no balancing needed. I can bring that 1, no changes. This one, though, it's missing a tangent of v, so I need to multiply the numerator by tangent of v. Okay, that's good to go. We know we can quickly merge them together to be the same fraction. Let's go ahead and resolve this denominator here. Again, same process, tangent of v being our common denominator. See if we need to do any balancing. No balancing needed here. But the second fraction, we're missing a tangent v. So multiply the top by tangent of v. 1 times tangent of v is just tangent. Okay, at least we can get this to be just a fraction over a fraction. Okay, so I have 1 minus tangent over tangent. All over 1 plus tangent over tangent. This is actually cleaner because we don't have kind of separate fractions all over the place. Now we just have a clean fraction over a fraction, and we should be pretty close to our answer. We should just dividing by a fraction, the same thing as multiplying by the reciprocal. So I'm just going to push this up to the top and flip the denominator fraction. Okay, what do you guys see here?
Okay.
Good. Now let's just push these two into one fraction, right? Numerator and denominator. Okay. Number 3. Tangent squared minus sine squared equals tangent squared sine squared theta. So let's see here. I know I see tangent squared on the right. I want to find a way to combine these together. But maybe the best way to do that is get sines to show up, because I know that I can play with tangents. I know tangent can be represented as in terms of sine, so what if I just make that conversion and see what happens there? So sine squared is tangent squared is the same thing as sine squared over cosine squared. And then sine squared is just over 1. So at least I get tangent into something that's familiar or similar to that second trig function. I know there's that cosine square sticking out, but at least we know that we have a much easier time working. We can always convert cosine to be in terms of sine. So it's much easier working with sine and cosine than tangent and sine. Okay. So now I'm seeing, okay, maybe there's an opportunity to merge these two fractions together if I find a common denominator. So my common denominator is cosine squared. Balance my fractions here. Nothing changes with my first fraction. My denominator is matching, so I'm just going to bring that sine squared over. Second fraction, I'm missing a cosine squared, so I need to balance the numerator with also a cosine squared. So I'm left with sine squared, cosine squared. At least I have the same fraction here, so I'm going to put it all under one fraction. I know it doesn't seem like as if we're making much progress here, but look at this numerator here. What can we do? Anything stand out to you here? We can't cancel out, but we can take out a what? Sine squared. See, there's two terms. They both share a sine squared. Let's pull that sine squared out. We're left with 1. Basically, I'm dividing each term by sine squared. Sine squared divided by sine squared is 1. We divide the second by sine squared. I'm left with just cosine squared. So I'm pulling a sine squared out. A 1 remains. Okay, we're actually pretty close here. What do you know about 1 minus cosine squared? Equals sine squared, right? We go back to our trig Pythagorean identity, right? 1 minus cosine squared is sine squared. So we know this is something, right? That matches nicely with that sine squared. Now I want to point this out to you. What's sine squared over cosine squared? Tangent. There we go. You got tangent squared here. You got sine squared here. We've reached our destination. Okay, number 4. Tangent to the fourth plus tangent squared equals secant to the fourth minus secant squared. Okay. Anything stand out to you here? Say it again. Raised to the fourth. Okay. What can we do to put this in a different form? Factor. Yeah, GCF. Right? GCF. What's my common factor? Tan squared. So if I divide both terms by tan squared, tan to the fourth divided by tan squared gives us tan squared. Tan squared divided by tan squared is 1. Okay. Recognize anything? The diagonal identity. Okay, so I can replace that tan squared plus 1 with secant squared. So I want you to pay attention to this here. You see how everything's in terms of tangent, but everything on the right side is in terms of secant? Can we convert both of these to be in terms of secant? I think so, right? So let's look at it piece at a time here. Tangent squared is equal to minus 1. Okay, so I'm going to replace that tangent squared with secant squared minus 1. And then the tangent squared plus 1, I can replace this piece with secant squared, right? At least we have everything in terms of secant. So what can we do here to hopefully make it look like this? Distribute. Let's see what happens. Distribute the secant squared through. Secant squared times secant squared is secant to the fourth. Secant squared times 1, or negative 1, is minus secant squared. There we have okay, number 5. I think we've seen something like this before, where we can't really involve any identity. We can't really convert to be a different trig functions already in the same trig function. So I'm going to try to make something out of nothing. I want to involve sine in the denominator. Maybe I can convert this to be a sine squared, and I can move that, get a conversion to happen with that cosine. So I'm going to start with this 1 minus cosine over sine. If I want to convert that sine to be cosine, I can always create a situation where I can introduce an identity. I know I can play with sine squared, so I'm going to force that sine squared to show up. But if I do that, I need to make sure I balance the numerator as well. Okay, we can play with that sine squared. That sine squared can be replaced with 1 minus cosine squared. Okay. Okay, hopefully we've done this enough times where you can recognize that, okay, if I want to get these to match, go through my factoring step, right? Difference of squares, break this down into 2 parentheses, and I can hopefully get a matching pair to make that go away. Difference of squares, a a squared minus b squared becomes a minus b times a plus b. And now that I have a matching pair for 1 minus cosine theta, I can make them go away. Now I'm just left with sine over 1 plus cosine, and that is the goal that we're shooting for. Okay, number 6. We start with 2 separate fractions, and we're trying to get it down to 1 term. Okay, what are you thinking about when you see this? Yeah, common denominator, right? I got 2 separate fractions with 2 separate denominators. Let's get that to be 1 fraction, and then we can hopefully have something show up. Sorry if you're still copying 5. Okay, so number 6, my common denominator. Oh, yeah, so let me ask you this. What is the common denominator? What's something that both the denominators can multiply into? Say it again. So if 2 pieces look completely different from each other, then we need both pieces to create the common denominator. So the common denominator is going to be a sine and a 1 plus cosine t. Right? We don't have to find super clever ways to create a common denominator if they're different. Just include both of them. We're going to need both of them to make our common denominator. So we got to go through our balancing act here. What is different between my old denominator and my new denominator? Sine. So whatever is missing, I need to make sure I include it with my old numerator. So balancing sine t times sine t gives me what? Sine squared, okay. What's missing between this denominator and this new denominator? 1 plus cosine, so I need to multiply this by 1 plus cosine. Okay, this is a little messier here. I'm going to go ahead and just FOIL this out and put it here, okay? So 1 plus cosine times 1 plus cosine, I get 1 plus cosine of t plus cosine of t plus cosine of square t. Okay, it's a little messy, but I'm going to try to combine some of this together into 1 fraction. Okay, is everybody okay seeing the 2 binomials and getting each of the terms? Okay, I'm just distributing the 1 through and the cosine through. Okay, so here is everything under 1 fraction. Sorry, this is cosine t plus cosine t. I'm going to merge that together to be 2 cosine t. Okay, at least we have it down to 1 fraction. Okay. You guys see anything here? Anything in the numerator that catches your attention? Yep. There it is. What's sine squared plus cosine squared? 1. So I can replace that with just a 1. So if this is 1, then I can make it 1 plus 1, which is 2. Okay, all right, so 2 plus 2 cosine of t Okay, I don't want to go too fast here. Do you guys see how we were able to get from this numerator to this numerator here? So I merged the sine squared and cosine squared to be 1. There's another 1 here, so I made 1 plus 1 to be 2, and I got 2 plus 2 cosine of t. Okay, we're getting close. The numerator and denominator is beginning to look a lot alike. What can I do here, though? What's shared here? I can factor out a what? 2. Okay, what do you notice here? Are we close? 2 over sine t. We know cosecant is the reciprocal of sine, so you can think of it as 2 over 1 over cosecant of t. You know that sine and cosecant are reciprocals. So now if I just divide by the fraction, I can multiply by the reciprocal, right? There's my matching part. Okay, number 7. I see cosine on the left. I see secant on the right. I know there's a relationship there. Cosine is in terms of a cosine. I know it's a reciprocal for secant, so I'm going to try to get it in terms of secant. Right. Replace cosine with 1 over secant because cosine and secant are reciprocals. Common denominator within the numerator and denominator. Once I get my numerator and denominator cleaned up with each individual fractions, then I'm going to move the denominator up. But I need to resolve these fractions, right? So I need to find a common denominator. So I'm going to balance. I'm going to take care of the numerator first here. Balancing needed. This is really 1 over 1. It's missing a secant, so I need to multiply this numerator by secant of x. So I get secant of x plus 1. Okay, at least I have common denominators. I can push those together later. This space is also sharing a common denominator for of secant of x. Balancing required. I need a secant of x to get from 1 to secant x, so multiply the top by secant x. The second fraction doesn't require any balancing, just move that 1 down. Okay, we got through the hardest part. Okay, next part, we can just kind of merge those two fractions together, and then we can move that denominator up eventually. Good. At least we're down to a fraction over a fraction. Okay. Dividing by a fraction is the same thing as multiplying by the reciprocal, so let's do that. Okay, this is going to work out cleanly for us. What do you see? Okay, secant goes away. push those together as one fraction, and I have the right side showing now. Questions so far? Okay, number 8 is messy. I don't want to put you through that just yet. Let's come back to it later. Okay, let's go to the next page. Okay, let's do 4 more, okay? And then we'll stop for the day. All right, we want to be able to get the left side to turn into secant theta. But right now I'm just trying to think, all right, what can I do to get everything to look alike? So let's just go ahead and convert everything to be what? Sine and cosine, right? Let's just get that. I know you're not seeing sine and cosine on the right side, but that's the easiest way to merge things together, right? Just get everything to look alike. So we know cosecant can be represented as 1 over sine. And then tangent is what? All right, this is easy one here, right? Sine goes away. And what's 1 over cosine? Secant. And we're done. Okay, number 2. Secant squared minus tangent squared plus tangent theta over secant theta. Okay, I see a bunch of squared here, so when I see exponent, right, when I see trig functions being squared, I'm always trying to think about, wait, maybe there's an identity that I can involve here. Do you see anything that we can maybe use?
Secant and secant squared and tangent squared, we can simplify that to 1.
Good. Secant squared minus tangent squared. See that relationship there? If I subtract tangent squared from both sides, I can make 1 equal to secant squared minus tangent squared. So that's a quick way to just get rid of that messiness there. Okay. Well, at least we have a simpler fraction to work with. Any thoughts? I think that could work. But I'm thinking something else, maybe a little bit easier. If there's only one term in the denominator, one way is, what if we can split this up into individual parts, right? I have 2 separate terms here. Can I make 2 separate terms out of this? Yeah, I can do 1 over secant plus tangent over secant. The tangent over secant is unresolved, but if we think of it as 2 separate terms, then we can just treat them, kind of solve them individually, right? Okay, 1 over secant is easy, right? This will just turn into what? Cosine. So we know this is done. Our job is trying to get this to show will turn into sine. So now maybe I'll convert everything to bring to sine and cosine. Okay. Tangent becomes sine over cosine. Secant becomes 1 over cosine. Dividing by a fraction is multiplied, same as multiplied by the reciprocal. Okay, can we get sine to show up? Yes. So there we have it. 1 over secant becomes cosine, and this mess becomes sine, so we have it. Okay, just 2 more. Cotangent of negative theta. Okay, this is an even and odd property here. What can we do with cotangent? Is cotangent even or odd? Yeah, only secant and cosine are even. So the odd functions, what can we do with this negative? Yeah, just put it all the way out. Okay. Okay, this should be pretty easy here. What do you think we can do here? Everything in terms of sine and cosine, right? Because we're seeing cosine here. We're hoping that when we do that, a bunch of stuff will cancel out and we're left with just cosine. And you flip that fraction up. Reduce, reduce. Negative cosine is our end goal. All right, last one here. So I'm trying to get all that binomial into one term. So I'm just going to FOIL everything out and see what I can do from there. Okay, so bear with me here. This is a little bit longer. I'm just distributing through. Okay, I'm thinking, okay, this looks like a jumbled mess here. I'm just going to convert everything in terms of sine and cosine. These are similar. I can push these together. And these are similar. I can push those together, right? We have 2 fractions that share the same common denominator and 2 that share the same common denominator. We have to merge everything together, but let me just get all the easy pieces to come together first. So this is 1 minus sine theta. I'm just putting these as one fraction here. So just combining the numerator, 1 minus sine theta. So let me kind of show what I'm combining here. I know I can merge these together because they both have the same common denominator. Okay, and then the other 2, I'm going to merge these together because they share the same common denominator. But ultimately, I'm still sitting at 2 fractions with different denominators. So common denominator, what's my common denominator that will allow me to merge these 2 fractions together? I need both a cosine and a sine, right? Okay, balance each fraction. The first fraction does not need any balancing. Just bring that 1 minus sign over. The second, though, is missing a sign. So I need to multiply this by sign. If I distribute this through, I get sine theta minus sine squared theta. Push all this together to be one fraction. Okay, anything go away here? Sines. I'm left with 1 minus sine squared. Anything? Can't do anything without 1 minus sine squared. Yep, make it what? Cosine squared. Okay, are we getting close? Any other cleanups you can do? And then we're left with cosine over sine, which is what? Yeah, there's our end. Okay, good. We'll be able to make progress tomorrow. Show me page 9 and 10.